This first video will be about transforming trig functions or circular functions. And really, it's no different from any transformation that we've done year 11, year 12. So the fact that it's a trig function really doesn't change a lot. So find the equation of the image of this under the following transformations. So remember, they need to be done in order. You can't sort of go, oh, I always do Dr. T or something like that, dilations, reflections, translations. They have to be done in the order stated. So we're going to dilate by a factor of 2 from the x-axis. Now remember, when we do transformations, we can do it two ways. All right? We can try mapping and we can try by equation. So I'll do mapping first of all. So let's get the mapping together. X comma y maps to. All right, dilation by a factor of 2 from the x-axis. So dilations from x change the y value. So x to y. Dilated by a factor of 3 from the y-axis. Dilations from y change the x. So we've got 3x comma 2y. Translated 5 units in the positive direction of the y-axis. Okay, so 3x 2y plus 5. 2 units in the negative direction of the x-axis in that order. What was it? Negative direction, was it? Yeah. So they're the transformations to create the image of x. They're the transformations to create the image of y. So we're going to say x dash, the image, is created by doing this stuff here. And y is created by doing this stuff here. Alright, so our original function is y equals sine x. Notice that we've got y and x in it, so we need to solve for x and solve for y. So we're going to go x dash plus 2 on 3 equals x, and we're going to go y equals y dash take 5 on 3. Alright, so what I'm going to do is pop that in for y, and I'm going to drop the dashes. Y take 5 on 3 equals the sine of this thing here, x plus 2 on 3, and there's my new function. But what I'm going to do is make sure I write it with y as the subject. So I'm going to go y equals 3 sine x plus 2 on, I can't read my own writing, 3 plus 5. Alright, I've got it. Okay, so now I'm going to try it via function. So the first thing I'm going to do is dilate it by a factor of 2 from the x-axis. So that's y equals 2 fx. Alright, now dilated by a factor of 3 from the y-axis. So that's y equals 2 f of x on 3. Alright. What's next? Translated 5 units in the positive direction of the y-axis. Y equals 2 f of x on 3 plus 5. And 2 units in the negative direction of the x-axis in that order. Y equals 2 f of, instead of x, we're going to do x take 2, still all on 3 plus 5. Alright, so all we're going to do is sub that in, so it's going to be y equals 2 f of that value means sine of x take away 2 on 3 plus 5, which is, ooh, it's not the same. What did I do wrong? Ooh, where did I go wrong? 5 units in the positive direction. Why did I get this one wrong? What's happened here? Oh, 5 units in the positive, 2 units in the negative direction. Okay, so there you go. So plus, plus. So rookie mistake. Alright, I'm going to leave this in the video, warts and all, just to show you that I'm certainly not perfect here. I would have done this absolutely by function if I was to do this kind of not by showing you, but just a question that I would do, and I would have got it wrong. So moral of the story is think carefully as you do each step. Okay, noting that this step here, you'll need to update to make sure that you've got shifting 2 units in the negative direction, you sub in x plus 2. So whoops, and my bad. Right, let's go the next one. dilated by a factor of 3 from the x-axis, translated pi units in the negative direction of the x-axis, dilated by this. Right, so I'm going to do this one via function, even though that last one didn't go particularly well. So the graph was y equals sine x. So we're still operating on that one. Dilated by a factor of 3 from the x-axis, that's 3 f of x, sine x. Translated pi units in the negative direction of the x-axis, so y equals 3 f of x, negative direction of the x-axis, x plus pi. I'm not going to make the same mistake again. Okay, dilated by a factor of half from the y-axis in that order. Alright, so watch out for this. When we dilate by a factor of half from the y-axis, what we do is we drop 2x into the function. Okay, so it's going to be y equals 3f of 2x plus pi. So instead of x, we replace it with 2x. Okay, now what some students will do is confuse this here and go 2 bracket x plus pi. So just watch out for that. Okay, it's this step here is not 3f of 2x plus pi. Okay, not this. Alright, so once we got this out here, all we're going to do now is rewrite y equals sine x with the transformations, which is 3 sine 2x plus pi. Okay, find the equation of the image of that under the following transformations. Alright, so again, I'm going to go by function. You can do mapping, that works just fine. You should get the exact same answer as me. So, you know, in your notes, include whatever you want. Find the equation of y equals cosine x under the following transformations. So we're dilating by a factor of 3 from x. So 3f of x, translated 2 units in the positive direction of the x-axis. Y equals 3f of, so positive direction, I'm being careful here, 2 units in the positive direction of the x-axis, dilated by a factor of a third from the y-axis. That means we sub in 3x for where we see x. Translated 4 units in the positive direction of the y-axis in that order. 4 units in the positive direction. So our transformed equation is y equals 3 cosine 3x take 2 plus 4. Okay, now we want to go from this to this. Okay, now these are a little bit harder, and I always use mapping. Okay, so if you said to me, do you always use function then? No. So I always use mapping when I want to state the sequence. Okay, I could try this via recognition. Okay, but I'm going to have all sorts of problems. In fact, let's just try it with both. All right, what I'm going to do is try it with function, and then I'm going to try it with mapping, and it should come out the same. Okay, so first of all, I'm going to try it using function, which is by recognition. Now, to state the transformations, what you have to have is a scenario where you have one single x. Okay, so the coefficient of the x term has to be 1. Here it's 3, and that's a problem. So what I'm going to do is rewrite this as negative 2 sine 3 x plus 2/3 take 1. Okay, once we've got a coefficient of 1 here, what we can do is state the transformations as Dr. T. So we can state the dilations first, the reflections second, and the translations third. Okay, but we can only do that when coefficient of x is 1. Okay, if we try it on something like this, what we're going to do is stuff the order. Okay, well, I will anyway. So let's do the dilation, so we can see that this is a dilation. So this 2 here is a factor 2 from x. This is a dilation factor 1/3 from y. Okay, now reflections. We can see this negative sign. That's a reflection in the x-axis. All right, now the translations. So we can see that it's a translation 2/3 in the, so this is plus 2/3. Okay, so it's 2/3 in the neg direction of x, or 2/3 to the left, and it's a translation 1 unit down. Okay, so that's by recognition using function. Okay, now what I'm going to do is try it using mapping, and in theory this will give us the transformations. Now they may be stated slightly different to this depending on what happens, so we need to be careful here, because mapping sometimes can give us a different set of transformations that work, but that just look a bit different. Okay, so let's just see what happens, and I think that's what might happen in this case. So we're going to go from y equals sine x to y equals -2 sine 3x plus 2, take 1. Ooh, tight for space here. Okay, so here what I need to do is just get sine x on the right hand side, or sine of something on the right hand side. So I'm going to go y plus 1 over -2 equals sine 3x plus 2. Alright, so we want to go from this to this. So we want it to look like this, we want it to look like this. So this is the image. Alright, now what I'm going to do, remember I called this, if you remember, pairing them up. Y equals y dash plus 1 over -2, and x equals 3x dash plus 2. Alrighty, so what we need to do now is work out what we solve for. Do we solve for y dash and x dash, or is this fine? Well, the way I like to think about it is x, y maps to x dash, y dash. These are the transformations and these are the transformations. So we need to make x dash and y dash the subject. Let's go x dash first. So we're going to go x take 2 over 3 equals x dash. So that's x take away 2 over 3. Now we're going to go this one, -2y take away 1 equals y dash. -2y take 1. Right, and now we're in a position to state the transformations. So we can essentially see here that this is a translation 2 units to the left and dilation by a factor of 1/3. But we can also write this one here as x on 3 take away 2/3. Oops. And leave this one. Right, so we can see that this is, or could be read as, dilation factor 1/3 from y and then 2/3 to the left, which is the way this one is stated. Okay, so again, I'm really careful with these questions when I mark them, because you might do it this way and get this set of transformations. You might do it this way and get a kind of different order depending on how you run the algebra and things like that. But ultimately, if you write down the transformations that are stated in this version or this version, your answer will be correct. So I'm going to write down this first version here. Okay, so it's going to be translation 2 to the left. Then it's going to be a dilation 1/3 from y. Then we're going to continue over here. We state the y ones. So we've got the dilation 2 from x, reflection in x, shocking handwriting, translation 1 down. Okay, so that would also be a perfectly correct answer. Right? Nothing wrong with that. All right, so again, the transformations you get are highly dependent on kind of your algebra and the process that you use. Okay, state, and notice again also, I'm banging on about this, but it says a sequence, not the sequence, but a sequence, which means that transformations can be a sequence. Okay, as long as it works, it's fine. Right, state a sequence of transformations that takes this to this. Okay, so I might just use flat out mapping for this one. So I've got from y equals half cosine 3x take away pi on 2 plus 4 to y equals cosine x. Okay, so we're going from this to this. This is our image. So we need to just change this one up. So I'm going to go y take 4. Then I'm going to times it by 2 equals cosine 3x take pi on 2. Alright, now I compare the y's with the y's. So I've got y dash equals 2 y take 4, and I've got x dash equals 3x take pi on 2. So x and x. Alright, so what do I make the subject? Well, this is how mapping works. So these transformations do this, these transformations do this, and we want the transformations. So we've already got them. Okay, so we don't need to make a any algebraic moves here. So we're going to say that y dash is 2 y take 4, and x dash is 3x take pi on 2. You could also expand that if you want, which will give you a different set of transformations than the one I'm going to give you. But I'm not going to expand, and I'm just going to leave it like that. So let's read them off. So x starts with multiplied by 3. This is a dilation factor 3 from y. This one here is a translation pi on 2 to the left. Now y has 4 removed from it, so this is a translation 4 units down, and this multiplied by 2 is a dilation factor 2 from x. Alright, so we've got those 4 transformations. Again, if you expanded this out, what you would do is state the dilation first, which would be 2 from x, and then the translation, which would be 8 units down. Okay, so that could be written in a different order as long as that goes 8 units down, not 4 units down first. Okay, alright, so good luck with those transformations as well.